Okay, hello, this is Max, and we're on our second problem of our tree abstract data type review. So this is a slightly different type of problem. It's asking us to confirm whether or not a tree that is passed in is a min heap. All right, so what's a min heap? Well, it's a tree with the special property that for every value in our tree, the parent is a lower value than each of its children, or a lower or equal value than each of its children. So right here, this tree is a min heap because we have 1 is lower than 5, 3, and 6. 3 has a smaller value than 9 and 4, and 5 has a smaller value than 7. This tree is not a min tree because you can see right here, 3 is a higher value than 2. Okay. So go back and watch the other videos if you don't remember what our selectors are. We've got root and branches for a single tree that we pass in. Root's going to get us the value of the tree, and branches is going to give us each of our subtrees. Okay, so here, since I'm just returning true or false, I need to think about the fact that I'm not constructing a new tree, and I need to decide what my base cases are going to be and what my recursion is going to be. All right, so for my base case, well, sort of our default thing that we think about for a base case is what happens when we're a leaf. Okay, so if isLeaf is true, what are we going to do? Well, if isLeaf is true, then we know that we have a min heap, right? Because we don't have any children, so there's no way for us to have children that are any smaller or bigger than us. So since all of our children we have an empty list of children, we're by definition a min heap already. Okay, so we'll just return true in this case. Okay, so we've handled our base case, isLeaf. I can't think of another base case. So if something is a normal tree, we're going to have to actually go through and check to see whether or not our tree has this min heap property. Okay, so how do we check to see if something has a min heap property? Well, now this is another classic thing that we need to do with trees. We're not going to go through and in a single function call iterate through every single one of our subtrees. So that would just be too much work, right? Because we could have potentially an infinitely deep or a extremely deep left subtree, right? And we don't want to have to handle that case in a single call to this node, right? So we're going to handle the things that we're responsible for at this level. So if we're making a call on 1 as our tree, and 1 has a root, right, and a list of branches, which come down here, what's the invariant that we need to make sure that is being maintained for a min heap? Well, for a min heap, we need our root value to be less than all of the values of our children. Okay, so if this case is false, our root is greater than, less than or equal to is actually fine. So if our root is greater than any of our child values, then we can just automatically return false, right? Otherwise, we'll need to make sure that all of our children are also min heaps. So we'll also need to check that each child is a min heap. All right, so let's do that. So first, let's handle our base case. So if isLeaf t return true. So this is sort of fundamental, right? If I'm just calling min heap on 2, then we know right away, all right, that's fine, that's a min heap, okay? And that's going to help us make this next set of code a little bit easier. Okay, so for now, for branch, or for B, in branches T, remember this is a selector that gets out a list of branches, which are all trees. For B in branches T, what do I need to check? Well, I'm going to first see if root T is greater than root B. So that's saying, in this case, if I called min heap on 3, I would check to see whether or not 3 is a higher value than 9. And if it is, then I would want to return false, right? And I can see that this happens in this next case. So for my first branch, I'm going to first inspect 9. And what do I want to do? Well, I want to see whether or not my invariant for min heap holds, which is that 3 should be less than 9, less than or equal to 9. That seems to check out. What else do I need to check when I'm looking at 9? Well, I also need to check that this is itself a min heap. So I should also say if not min heap, well, is min heap, B, then I also want to return false. Okay. All right, so I've checked to see that 9 is a value that is greater than or equal to 3 with this root t is greater than root b check. So if this is true, then I want to return false. And I've also made sure that 9 is a min heap itself. Okay, and in this case, since it's a leaf, it's trivially a min heap, and we can go check our next branch. So we've checked this out, so now let's look at 2. So here, root t is 3, and root b is 2, and so we find that our min heap invariant doesn't hold, and so we return false for this whole branch. Okay. And you could see that this would be a subcall to this big call that I have right here. This branch would have already checked out, and we'd be investigating to see whether or not this branch was a subtree, or that was a min heap. And since we find that it's not a min heap, we'll bubble up and return false from our root up here. So this is going to return false. All right, and we don't need to inspect this next branch. Okay, so if we've gone through all of our branches, we found that they all maintain this heap, min heap invariant right here, and they're also all min heaps themselves, then after our for loop, we can return true. All right, so this was an example of a tree recursion problem that doesn't involve building a tree. And the thing to be careful of when you're looking at one of these is handle your base cases, and then in your recursive call, figure out what you're actually responsible for at each level. So when I'm making a call to this tree here, I need to make sure that my heap invariant holds for the things that I have access to, which are the root nodes of each of my branches. And then I just am going to trust that isMinHeap is going to return whether or not each of my branches is a min heap. And in the case that any of my branches are not min heaps, then I know I can return false right away. One common problem that I see here is that people will check to see that a min heap invariant holds for one branch, and then they'll return true. So what's the problem with that? Well, if I return true here, just because one of my branches satisfies the min heap invariant, then I might have another branch later on, like this branch, that fails the min heap invariant. So you've got to make sure that when you're doing these as well, think about why returning true inside of this branches for loop is problematic. If you have questions about that, please feel free to post on Piazza, and we'll make sure you get them answered. And let us know if anything about this was unclear. All right. Good luck.